Hey guys, so today we're looking at how to remove the nth node from the end of a linked list. So given a linked list, we need to remove the nth node from the end and return its head. So given this linked list, 1, 2, 3, 4, 5, and if n is equal to 2, which means we need to remove 4, then we need to return 1, 2, 3, and 5. So let's have a look at how we can solve this. So I thought first we can just walk through how to remove a given node from a linked list. So given this linked list, where 1's the head, and we want to remove node 2, where m is equal to 2, so this is going to be the node to remove. So how can we do this? Well, we can do this by setting a new list node called previous to head, and then walking forwards a certain number of steps m, such that previous becomes the node just before the node we're about to delete. Note that if you're actually implementing this from head, you may need to add like a -1 onto here, but I'm just going to leave that off for simplicity's sake. So we have previous set to the node just before the node we're about to delete, and that's useful because then the node we're about to delete is previous.next, and the following node is going to be previous.next. So if we run previous.next is equal to previous.next.next, we essentially repoint this to the next node, and that means that we essentially remove this link. So now if we return head, our list becomes 1, 2, follow this, 4, 5, 6. So we've essentially removed this node from our list. Now one extra layer of complexity in this question is we're not actually given n. Instead, we're given some other integer n, which is supposed to represent the nodes from the end. It makes it a bit more tricky because in a singly linked list, we can only move in one direction. And in this example, we knew we had to move something like m minus 1 steps. If we're given something from the end, the situation changes a little bit more. And instead of m, we're going to have to do something like length minus n. So let me reset this and show you what it looks like when n is set to 2 and from the end. So let's just reset the linked list. So if it's n from the end, then this is going to be the node to delete. And we can use exactly the same procedure, except this time, instead of moving m steps, first we have to go through the whole list, and we have to work out what the length of the list is. Once we have the length, we can then go forward a number of length minus n steps, such that previous is going to be the node just before the node we're about to delete. And we can run the same command, previous.next is equal to previous.next.next, to repoint this. And we can see that if we return head now, we get 1, 2, 3, 4, 6. And also we've essentially removed this node 5, which is the second node from the end. So doing something like this is going to be order of 2n, because you've had to go through this twice. The first time you had to go through and work out what the length was. And once you have the length, you can actually start from the beginning again, and you can move forward of length minus n steps to set previous to be the node just before the node you're about to delete. So even though it's order of 2n, it is still an order of n solution, but there is a way you can do this just by looping through once, and we're going to go and discuss that now. So I've reset the linked list, and we're going to go through the solution now where you can just do this in one iteration. So we saw last time, you typically have to do something like length minus n steps in order to set this node previous to be the node just before the node you're going to delete. And the reason you want that is because you want to do something like this, which lets you jump over the node that you want to remove. So one way we can do this is to have some list node, call it lead. I can set this list node to be right at the end of the list. And you may be able to note that the distance between this lead, which is effectively at the end, and this previous node is going to be n. So we can have a separate pointer here, call it lag, which points at our previous node, and it's going to be the node just before the node we're going to delete. So we effectively have a sliding window. So let me just show you how this is going to be implemented. So we have some dummy node here, which we'll come on to a bit later. But if I set lead and lag to be here first, I then increment lead the total number of n steps so that it goes to here. Once I have lead a total of n steps ahead of lag, we now have a window which we can then move, and we can move that all the way till the end. So lead would eventually come here, lag would be here, and we have this window. And at this point, because this is the node we want to delete, we can just run something like lag.next is going to be equal to lag.next.next. And that's just going to jump over this node we want to remove, effectively remove that node, sorry. So our linked list becomes 1, 2, 3, 4, 6. We remove this node by using the sliding window method. And this is going to be something like order of n, because we've effectively started from the start and we just go once to the end. So it's going to be order of n, and it saves us going through this list twice. In our first case, we had to go through once to find length, and we had to go through it again to position our previous node. In this case, using the sliding window, we can just go once. Now, one of the extra consideration we have to think about is if n is going to be equal to the length of the list. In that case, we might actually have to remove the head node of the list. So it's useful to have a dummy node. So you can set a dummy node. So dummy.next equals head. And this will just connect the dummy node to the head node. And this just means in the event where n is going to be something like 6, or the length of the linked list, you have some previous node where you can just jump over the node that you want to remove. And you'll see here that I've set lead and lag set to dummy first. And this allows us to remove the head node if we need to. So I can just show how this works in code. So I just have the code loaded on the right. So here we see we are making our list node, and then we're saying dummy.next equals head, and then we set the lead and lag set to the dummy node. We then move the lead pointer first, a total of n steps, and once the lead pointer is ahead of the lag, a total of n steps, we can then move the whole window all the way until lead.next is not equal to null, which moves lead right to the end, and that means lag is going to be right where we want it. And then we can just run lag.next is equal to lag.next.next. So you can see that this works. And then submit. And we can see that it works. So if you found that useful, please like and subscribe, and see you soon.